I'm happy to be speaking here. I'm Mathis, I work for Deepset. We have a platform that helps teams build with large language models, like ChatGPT. Basically, you want to have ChatGPT on your own data. That's pretty difficult, and we have a platform to help you with that. And today, I want to talk about kind of the shift that we are seeing with data science, software engineering teams in enterprises working with large language models, or how large language models basically shift their roles, shift their responsibilities, and how enterprises can approach and think about building with large language models. It's very high level, it's just what we're seeing, talking to our customers, talking to people in the market. So I'm going to start with what's actually changing with large language models. I'm going to talk about the challenges that teams face, so some of the things that we just see day to day. I'm going to talk about that actual AI team, so who is it building with large language models, and I have it in the title of my presentation, that AI team. I have two small examples of how to build with large language models and how not to build. And then, of course, there's a Q&A, and I'll try to answer all of your questions. Maybe just a quick show of hands. Who is thinking about building with large language models? Who is actively building with large language models? Who has something running in production? All right, checks out. Cool. So let me start with what's actually changed with large language models, how it changed the profession of a data team, data scientists, how it brought part of that to software engineering. I think the first thing that changed basically from 2018 to today, so 2018 was the birth of the transformer model, a LLM language model architecture that was a revolution at the time. And what you see here is over the years, the number of models being released and also their size. And you can really see that explosion in 2022, 23, when ChatGPT was released basically afterwards. But even before that, it really picked up the pace, and language models are just readily available. You can use commercial models, you can use open source models, and you don't need to build from scratch and start training your own models. It's just there and you can use it. And what's also changed is that these models are incredibly performant. So what you see here is a selection of large language models on a popular large language model benchmark. And you can see from GPT-3 that was released in 2020, you can see the progression, and it scored right over 40. GPT 3.5, which is like ChatGPT, scoring above 60 already, and then GPT-4 scoring above 80, which translates to basically incredible capabilities. And you can see the same for other models, like the Llama models 1 and 2, they increased their capabilities. Google's Palm model, probably the closest runner-up to GPT-4, almost at the same level. For many use cases, it might be at the same level. And what that performance means is that the role of a data scientist has really shifted. It used to be about training a model, fine-tuning maybe, and now they can just take a model off the shelf and build their actual use case with them. And that means that everything has gotten a lot faster. Previously, it might be, okay, we have this project, we need to collect training data, we want to train our own custom model. That's going to take half a year maybe. And now you're pretty much expected to deploy that first prototype within the first week, and then you can start testing with real users, can evaluate, benchmark, find the correct configuration, and then actually go to production in a matter of weeks or very few months. And that's an incredible shift and something that many teams struggle with, actually. So what are some of the challenges that we see these teams facing? One of them, and that might be a bit surprising, because I've just shown, well, GPT-4 is like available, it's incredibly good, but many teams actually struggle with model selection, because it's not just a single model that you need probably 2 or 3 models if you want to build a product, and there's just so many, and it's so hard to navigate which one to use. There's benchmarks coming out every day. It's hard to know, are these comparable? Do they apply to my use case? And that difficulty of actually selecting a model is also reflected by the models available on the Hugging Face Hub, which is like a popular place where open source models can be hosted and exchanged, basically. And just from the release of ChatGPT to today, the number of models on the hub almost doubled, or more than doubled, actually. So there's over 200,000 models, and now go ahead and pick one. Many teams are like in a paralysis analysis trap where they are unsure what to pick, and then that delays their project. Another thing that we see is that many enterprises right now, they're looking to build retrieval augmented generation. That's basically you connect a generative model like GPT or Llama to your data, and you have a second model that embeds your data into vector space, and then when you have a question, it retrieves matching data and then feeds that into the large language model to generate an answer. And this is incredibly hard to actually evaluate because of the nature of these generated answers. Many of the more traditional metrics for evaluation that come from academia, they don't work really well. And what we see successful teams doing is basically breaking it up a little bit. I just mentioned that component getting your data from the database, from your vector database. You can actually evaluate that in isolation pretty well. Iterate there because it's a very important component of your system. And for the generative model, we recommend sort of like a mixed method approach where you have a few model-based metrics, a few stochastic metrics, and then actually we always recommend to test with end users, do A/B testing, because you only really find out if it works if you try it out on your use case. So try it out end-to-end on your use case. And the minute you do that, it will basically 10x your progress because you find things that you would never have thought. You find like, oh, it doesn't work for this, but it does work for that. You find out how people are actually using these applications. So that's a benefit as well. So really, that's something that we recommend there. And then another thing that we see teams struggling with is actually the infrastructure and selecting the right application architecture. That's especially applicable for like data teams, data science teams, because they're not used to building production-grade software. It used to be, hey, I train a model, there's my MLOps team, I throw it over the fence at some point, they productionize the model, and then the actual application developers start working on it. What we now see is more integrating all of these roles, and then it's quite difficult to actually figure out what components you need, what architecture you want to have. So that's something that we definitely see teams struggling with. I want to now shift from the challenges to the actual team that I've been talking about. So we see there's two emerging things, basically. We see an emerging like AI team. So many companies are like, okay, we're going to assemble an AI team, and that's not going to be our data science team. It's also not going to be a software engineering team. It's something else. And many people are actually thinking about this, like how do I structure my AI efforts at my company? And this is a quote from Sarah Guo, investor, the AI native VC. And she says, basically, because these models are so performant, you don't need data scientists, researchers anymore. You need them, but 99% of AI products will actually be built by software engineers. So something that software engineers before, they didn't do that. They built like products, applications without AI, and now that's happening. But then you have other people who say like, well, these data teams, they have incredible expertise in like providing clean data, diagnosing a system, finding errors, evaluating, and so on. And they're going to be the ones monitoring everything once it's in production, and then tuning everything and making it better over time, basically. And what I think is that what you want to do is basically combine both of them. You need that data expertise, like that data scientist. You also need your software engineer, product engineer, because data professionals, they're very good at providing that clean and standardized data. They know about model selection. They know about quantitative evaluation. They maybe have an emerging skill of prompt engineering. And then product or software engineers, they can design the application architecture. They're used to actually building resilient systems that don't fail in the first minute. And they're also much more accustomed to working with the end user in mind, doing user interviews, for example, working with product and design. And that's really important in this age of new interactions between humans and machines, essentially. So the way we're thinking about this is that you want to have that AI team if you want to be successful with your large language model applications. Something that we are also seeing is an emerging role of an AI engineer. So kind of the combination of both. And I think for many companies, they will have like these generalists who are like, maybe they were software engineers, but they got really interested into the NLP, large language model side of things, and then upskilled there, and then they can kind of cover both. Same can be true for like data scientists coming from the other side, getting more skilled in actual software engineering. So that's basically the team structure that we're seeing. And then when these teams start to build something, we see kind of two patterns, and there's a lot of variations of these patterns, and it's just something that I hear when I talk to people. I give a lot of talks and webinars. I always have like questions and people who approach me afterwards, and then I can hear like from them how they're thinking of approaching this problem. And one approach that we've seen, and I would position that as the approach of how not to do it. I had like a data science leader talking to me in an enterprise. He was like, yeah, right now, well, we're building our training platform because we want to train our custom LLMs from scratch. And then, of course, we want to have our own inference platform to really have everything tuned to our needs, and we want everything in-house, and we gotta need to build that platform. And then finally, well, you have the model trained and you have inference, so you can get predictions from a model, but to build an actual product or application, you need a little more. You need to orchestrate that, you need to combine models, you need to run experiments, track them, run A/B testing with end users. So finally, they're gonna build a custom toolchain platform. And I was like, well, is your company in the MLOps space? And he was like, no. I was like, yeah, it's probably not their core competency, and they can do that totally, but they're gonna spend like 2 years. 2 years might be irrelevant already. So if you want to tackle large language models now, really what you should do, and this is an example from another team that we've been working with, is use a large language model that's readily available. I think if you think that you can train something that is better than GPT-4, you're wrong. That's very, very difficult. There's very, very smart people working on that for years. So that's probably not going to happen. you should also basically rely on what's there, commercial MLOps tooling. There's also great open source MLOps tooling, but really like don't try to build your own platform from scratch. Then, as I said, getting your live prototype running ASAP, really 10x your velocity on your learning is the most important part for me of the build process. Like I'm always impressed when I see teams like getting first user feedback and hands-on experience, and then optimize on small and fast iterations. And once you go live, you can start actually learning about how people are going to use your product. And yeah, that's essentially how we're thinking about being fast and building good, well-working, stable LLM applications right now. And I'll have time for questions now.